Hello. In this video, I will do an Alex math practice exam 2. So let's do this Alex practice exam 2. Okay. Question 1 says find 3 over 7. 3 over 7 is equal to or equivalent to these choices. Yeah, there what I would do on this one, if you could literally put 3/7 in the calculator if they allow calculators on certain problems because they don't allow sometimes they allow calculators on certain problems. But if you put that in the calculator, that's about 0.428. And then what I would do is just test each one. If it gives me a decimal of that of 0.428, that's the one. But what I would do is I would eliminate C and I would eliminate B. Why would I eliminate? Because those cannot be reduced. 3/4 cannot be reduced. The same thing with 7/3. So there is no way it could equal to 3/7, right? So let's try A or D. So let's start with A. So you have 18 over 42. What I could do is probably try to reduce this by what? 6. So 18 divided by 6 is 3. 42 divided by 6 is 7. There you go. There's your answer. So 18 over 42 is the same thing as 3/7. Okay, question 2. Determine the length of x given in the figure below. Well, we have these two triangles. We somehow got to find it. Now, I don't think these triangles are congruent. Um, why do I don't believe they're congruent? Because there's nothing with related to their side lengths, right? You don't have a side length that's this, and then no. But what I do see is you have some angles that are congruent. It looks like all these angles are congruent. See how this has one tick mark? So this angle is congruent with this angle. And then this two tick marks is congruent with this angle because it has two tick marks, etc. So there's a good chance I believe it is similar because in a similar triangle, the sides aren't congruent. They may be proportional, but in a similar triangle, all the angles are congruent. So let's try to set it up as a similar triangle. So similar triangle proportion. Thing is, let's see. So what do we have? We have 7 centimeters and 20 centimeters. Um, yeah, we don't know if 20 is the hypotenuse or 7 is a leg, right? Or 20 is a larger leg and 7 is a smaller leg, right? So we can't really set it up as a proportion, right? Because 20, for example, yeah, I cannot tell if this is a leg, a larger leg, or a hypotenuse. There's nothing about their side length. So, and if you try setting up, for example, 20 has two tick marks. So if you want to do here, that'd be 2. And then 7 is facing this one tick mark. Now, if you have, that has to be the same rule for this one. So where's the two tick marks? Right here. See, there's no side lengths for this tick mark, so we can't use this. This is a trick problem. It is going to be C, right? Do not try to do x over 4 and somehow give you b. No, that's false because their side lengths has to be related to their angles. So it is definitely C, not enough information. Okay, question 3, solve the proportion. This one's easy. We have x over 7 equals 3/8. Why is this easy? Because there's only two sides. You have the left, and then you have the right. Now, if you only have two sides, if you have more than two sides, like three sides, you have to get rid of the denominator by multiplying both sides by the LCD. So you can either, there's two options. You can cross multiply, or you can multiply both sides by the LCD. Okay, I'm just going to cross multiply because it's just easier for me. So go ahead and cross multiply. 8 times x is 8x equals to 7 times 3. That's 21. And then solve for x by dividing both sides by 8. And you get 21 over 8. Do I see my answer? No, because we can reduce, right? I think it could be reduced by, wait. Yeah, actually, no, it cannot be reduced. I want to say 3, but no. I want to say just 8 divided by 3, it doesn't come out nicely, right? I want to say 7, no. I would have to say A. Question 4, what is the surface area of a cube? So when we are doing with cubes, they're basically like squares. Each face is a square, right? In a cube, there's 6 faces. If you know what is the area of one face? So a cube is basically squares, area of one face. Uh, so they're saying that this length is 5. So that means all sides are going to be 5. This is going to be 5. This is going to be 5. This is going to be 5, right? Everything is 5. So what is the area of a square? It is length times width. 5 times 5, which is 25. So we want the total area or the total surface area. So all you got to do is multiply 25 by 6, and you get a surface area of 150. Question 5, the altitude A of a certain plane during a ascent is 70% of the distance d the plane has traveled plus an additional 1,000 feet. Which of the following best represents the altitude of the plane as a linear equation in terms of d? So if you look at all the choices, they're all linear in a linear equation. It's in the form of y equals mx plus b, right? So what do you think it will be? This one, I believe it's going to be, so you could think of the area, the altitude equals 70% of D, just like your M. So this is your M, and then your B is your starting point with an additional 1,000 feet. Okay. Now, how do I write 70% of D? Well, how do I convert percentage decimals? Move it 2 units to the left, so that's 0.70, and then of means multiplication plus 1,000. So 0.70D is 0.70D plus 1,000. So that would be C. Okay. Question 6. If 7 plus 5x, I mean, parentheses, 7 plus 5x equals 2 times 7 minus 1y, what can you deduce? What can be deduced? So what I would do is kind of simplify this, right? So on the left, I would do the inner parentheses with 7 plus 5, 8, 8, 9, 10, 11, 12. And then over here, I also do the parentheses 7 minus 1 is 6. Times it by y. The 2 times 6 is 12y. And then this is 12x. Okay, so what must be true? If x is greater than 1, I don't think that's true. If x is 1, I mean, or x is 2, and y is 1, the left will never equal to the right, right? I don't think so. Uh, b, x cannot equal y. I think they must equal to y. I think they must be the same. So for example, if x equals 1, y must equal 1. Let's plug that back in into this equation. And is the statement true? Yes. 12 times 1 is 12. 12 times 1 is 12. Definitely true. So I would say D. Okay, this one. 7. We have negative 32 over 5 times 4 eighths equals minus 22 over negative 10. So what I would do is kind of clean this up a bit. So over here, you're multiplying fractions and hold on. That's my writing template. Over here, what I would do is simplify. How do you simplify a fraction? You multiply across, right? So what's negative 32 times, or actually, what could I do before I multiply this? I could reduce the 4 eighths, which could be reduced by 4, so that'd be 1 over divided by 4 is 2. And then you have negative 32 over 5. Then you may multiply across, so this is negative 32. And then 5 times 2 is 10. Minus a minus 22 over 10. And then 22 over 10 can be reduced by 2. So that would be 11, and over 2 is 5. And then over here, what's negative 32 over 2? I think that could be also be reduced by 2. So that would be negative 32 divided by 2 is negative 16. And then 10 divided by 2 is 5. Okay, see how the bottoms are good? So when you're adding fractions, you need an LCD. So the bottoms are the same, so that's good. So my LCD is 5. And then on the top, what's negative 16 plus 11? Negative 5. And then what is negative 5 divided by 5? Negative 1. D. Okay, 8. Transferring X pounds of materials by truck costs $3 per pound plus an additional fee of 50. Which expression below represents the total cost to transfer X pounds of material? So this is just a simple linear equation. Y equals mx plus b. The b is like your starting point. So I think it says additional fee of 50. So that's our starting point. I think our b is 50. And then our slope is like the uncontrolled cost. So it says it's $3 per pound. So I think it's going to be 3x. Okay. Okay. This one says find the solution to the following system of linear equation. So what you got to do is it's already kind of set up, but the method this is a system equation. See how you have two linear lines? This is a linear line, this is a linear line. What I would do is I would do the elimination method. I mean, sure, there's two, usually there's actually more than two ways. There's elimination, substitution, matrix, and then I believe Kramer's rule would also work. But I like elimination because it's so much easier. So what letter would I get rid of, or the easiest to get rid of? I'm going to say X. See, you have a negative 4x and 1x. To get rid of the x, I would have to multiply the entire second equation by positive 4. Okay. I didn't do anything with equation 1, so I'm just going to rewrite it. Equation 2, I got to multiply everything by 4. So 3y, the x, and the 10 by 4. So 3 times 4, I mean 4 times 3y is 12y. 4 times x is 4x. 4 times 10 is 40. And then the x cancels. And then 12y plus 7y is 19. And then 20 plus 40 is 60. Divide this by 19, and you get y equals 60 over 19. Now, I don't think 19 can be reduced, so I think it's prime. So I do believe this is our answer for the y. So, uh, I mean, it could be, if you have a time limit, I would just pick C because it's the only one with the y value of 60 over 19, right? Um, Now, if you want to find the x, what you could do is plug in y back into, um, you could put it here, the first one. Oops. So replace y with 60 over 19. So 7 times 60 over 19 minus 4x. And then 6, I mean 7 times 60 is 420 over 19 minus 4x equals to 20. Oops, forgot the 20. And then to solve for x, I would have to get rid of the fraction by multiplying everything by 19. And when you do it all, you get this 10 over 19. Okay, so it is definitely C. Okay. Question 10. Evaluate the following piecewise function, a piecewise defined function when x equals 20. So we have this piecewise function. Basically, what a piecewise function is basically more than one lines put together, right? So the first line is a linear line of 3x plus 2 where x must be less than 4. And then the second line is also a linear line as 18 minus x, where x is greater than equal to 4. So which one do we put, where do we plug in our 20 in? Do we put in the first one or the second one? You just have to look at the domain. So the first one says x must be less than 4. Is that what our x is? X is 20, which is not, definitely not less than 4. So you can forget about the first equation. Is it the second one where x is greater than 4? Yes. 20 is definitely greater than equal to 4. So you're going to use a second equation and then replace x with 20. So that's 18 minus 20. And then 18 minus 20 is negative 2. Okay, second one, what is the slope of the line? So what I would do is I'm not gonna just eyeball and figure out how much rise and how much run. What I would do is pick two random points and use the slope formula. That's it. So I need two exact points. So I see an exact point right here, and then that point is negative 5 comma 5. And then I also see another exact point here at this point, so that's 15 comma 0, right? And then what I'm going to do is use the slope formula, which is y2 minus y1 over x2 minus x1. So here's my x1, here's my y1, here's my x2, here's my y2. So m is y2, which is 0, minus my y1, which is 5. My x2 is 15, minus my x1 is -5. Clean it up. What's 0 minus 5? -5. Two negatives becomes a positive. 15 plus 5 is 20. And then I believe that 5 can be reduced. So this is going to be -1. 20 divided by 5 is 4. Okay. Not too bad, right? Question 12. Consider the Considering the graph below, which option best represents the line reflected across the y-axis? So here they give you this graph, right? And they want us from these choices, which one represents a reflection of this graph? So a reflection across the y-axis. So what you need to know is what is the rule of a reflection across the y-axis? It's basically this, x comma y. So whatever your coordinate is, it now becomes -x comma y. Okay. So yeah, that's what you're gonna do. Um, so what I'm gonna do is pick a point. Let's use, I don't want to use this point, and I don't want to use this point because they have a 0. Let's use this point. So that point is at 5 comma 10. So what would be the new point after the reflection across the y-axis? Well, according to the rule, you make the x negative, so it's going to be -5 comma 10. So which of these graphs has a coordinate of -5 comma 10? Is it the first one? No. -5 comma -10 should be somewhere here. No. Is it the second one? Not quite. -5, -10 should be right here. This one? No. -5, wait, -5, +10. Yeah, I think that might be it. Yeah, -5, +10. Let me double check the last one. No. -5 comma 10. No. So it looks like it's C. Question 9. In completing the square, which of the following expression is equivalent to the quadratic 2x squared minus 8x plus 21? So basically what they want is just they want you to rewrite this using completing the square method. So what I would do is set this to 0 first. Then what I would do is after I did set that to 0, I'm going to move the constant to the right side. So this 21 is my constant, so I'm going to move that to the right by subtracting 21, right? Now I have 2x squared minus 8x, and then leave a little blank space, and you'll see why I left a little blank space. And then on the right, 0 minus 21 is -21. Okay, so what do I put in this blank space? Well, uh, you take half of every b and you square it. But before I do that, between the 2x and squaring the -8x, it looks like I can factor out 2. So this is going to be x squared minus 4x, and then blank space equals to -21. So what do I put here? It's your b, which is -4. Take half of that is -2. And then you're going to square that, which is +4. Now, you would think you would have to add 4 to both sides, but we did take out this 2, so it's really 4 times 2, which is 8. So you're going to add 8 to both sides. 8 here and 8 there. Let me put it right here. So now we have 2 parentheses x squared minus 4x and then 8 And then on the right, negative 21 plus 8 is negative 13. Okay. Then what I'm going to do is put this in factor form. So it's going to be 2x and then go backwards. So half of your b, so your b is negative 4. Take half of that, that's negative 2. Close it with parentheses, square that equals negative 13. And the last final step is I'm going to move this constant to the left by adding 13 both sides. So in your fact, you get 2 parentheses x minus 2 square plus 13. So it looks like it's C. Okay, 14. Solve the following quadratic inequality. We have minus parentheses x minus 3 squared plus 8 is less than or equal to 0. And no, it's not as simple as just solving for x. This is what's called a test point method. So when I was doing this, I thought maybe you just solve for x. No, it's it's a test point method. So what you got to do first is make sure it's one side. Make sure the one side is 0. It is, right? Double check. Or what would I do first is what I would do first, yeah, move that 8 to the left. So this cancels. Now you have negative parentheses x minus 3 squared is less than or equal to negative 8. Then what I would do next is get rid of this negative 1 by dividing both sides by negative 1. So you get x minus 3 squared. And then because I divided by a negative, you do have to flip it. So it's going to be greater than or equal to 8. Then what I would do is FOIL this out. X minus 3 squared, it is not x squared minus 9. It's when you FOIL it out, it's going to be x squared minus 2 times AB. So that would be negative 6x plus 9 greater than or equal to 8. Then what I would do is get one side 0. So then I would move this 8 to the left by subtracting 8. So I get x squared minus 6x, and then 9 minus 8 is 1, greater than or equal to 0. Okay, so once I have one side 0, and it's look at the symbols greater than or equal to, so that means we only care about the positive sign. If it was less than or equal to 0, that means we only care about the negative. So you'll see what I mean by positive when we put it on the test line. But yeah. Then what I'm going to do is solve for my x. So for right now, I'm going to leave it as a equation. And then what I'm going to do is solve for x. So unfortunately, we can't factor this out nicely. Um, it doesn't factor out nicely, right? So how are you going to factor this? I'm going to have to use the quadratic formula. So my a is 1, my b is negative 6, and my c is 1. So it's going to be x equals opposite of b, which is 6, plus or minus root b squared. So b is negative 6, so b squared is 36, minus 4 times a, which is 1, and c is 1, all the way to a. And you get, so when you put that in the calculator, you get 36 minus 4, that's 32, all over 2. And then Square root of 32. What you could do is simplify square root of 32. It doesn't come out nicely, but you can break that down into 8 times 4. 4 could be broken down as 2 and 2. 8 could be broken down as 2 and 4. 4 could be broken down as 2 and 2. So circle pairs of 2, so this is 2, and then this is 2. What happens is this 2 just becomes 2. This extra 2 and 2 just becomes 2. And then you have 2 here. This remainder of prime number, so that's 4 square root of 2. Okay, so I know it's confusing. So we just simplified square root of 32. So now it's going to be x equals 6 plus or minus, and then replace square root of 32 with 4 square root of 2 all over 2. And when you clean this up, you divide each term by 2. So 6 divided by 2 is 3 plus or minus, and then 4 divided by 2 is 2 square root of 2. So you have two x values. One of your x value is 3 plus 2 square root of 2. And my other x value is 3 minus 2 square root of 2. Okay. So if you look at all the choices, the only one with the 3 plus 2 square root of 2 is A. But notice, look at the sign. X is less than equal to, why is the sign x is less than equal to and x is greater than equal to this? This is where you do the test point method. So here are my two x values. If you put 3 plus 2 radical 2, believe it or not, that is going to be, that's about 5.8. And then if you put 3 minus 2 radical 2 in the calculator, that's about 0.7. So what you want to do is put the larger x value to the right. So this is 3 plus 2 square root of 2. And then the smaller x value on the other side. So we have 1, 2, 3 regions we got to test. So what 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 equation are we going to put it? We're going to put it in this one right here. Okay. So let's test region 1. What's a number smaller than 3 minus 2 radical 2? So we say that that is about 0.7. So a number smaller than that, you can do -1. Now, I don't care about the number itself. So when I plug in -1 to this, it spits out 8. Now, I don't care about the number. I only care about the sign. 8 is positive, so you're going to put a plus sign here. And then region 2, what's a number between 3 minus 2 radical 2 and 3 plus 2 radical 2? Let's see. 7. You could try 2. Yeah, 2. And when you plug in 2, it spits out -7, so you put a little minus. And then region 3, what's the number larger than 3 plus 2 radical 2? 7. And when you put that in the calculator, you get uh I think it's gonna be positive. It's like 7 square minus 6 times 7 plus 1. Yeah, it's definitely positive. Okay, then what we go, remember we only care about the positive sign, so we only care about region 1 and region 3. We don't care about region 2 anymore. So it's going to be A, right? X is less than 3 minus 2. That's true. Like if you put this in interval notation, it's from -infinity to 3 minus 2 radical 2, right? Which is the same thing as this. X is less than equal to 3 minus 2 radical 2. And then if you put this region 3 in interval notation, it's basically 3 plus 2 radical 2 comma infinity. So yeah, yeah, that was a difficult one, huh? Yeah, it took some time. Okay, 15. Here's an easier one. We have 12.2459 times 10 to the 3 positive 10 to the positive 3. So this one, because wait, 2459, because it's a positive 3, you just move it 3 units to the right. So here's your decimal place. Move it 3 units to the right. So 1, 2, 3. That's 1, 2, 2, 4, 5.9. Okay. Find the zeros. So basically, when you say find the zeros, basically say find the y-intercepts. I mean, the x-intercept. So how do you do that? You set g of x to 0, and then solve for x. So what you could do is you want you can set each equation to 0. So x minus 3 to 0, x squared minus 36 equals 0, and then x plus 4 equals 0. So over here, I'm going to solve for x by adding 3, adding 3. You get x equals 3. Over here, until in order to solve for x, you're going to add 36, add 36. You get x squared equals to 36, and then square root. Square root of 36 is 6 and negative 6. And then over here, to solve for x, you're going to subtract 4, subtract 4. You get x equals negative 4. Okay, so we have 3, 6, negative 6, and negative 4. It's the first one, right? We have 3, 6, negative 6, and negative 4. There you go. Okay, this one, what is the cosine theta? So this one here we have a right triangle. We have these two side lengths. They don't give us any side, it's just letters. And then they gave us theta. And we know it's a right triangle because it has that puck symbol. And we got to find out what is cosine theta. So when you could use this SOHCAHTOA because it's only related to right triangles. So cosine theta is adjacent over hypotenuse. So what you want to do is here's theta. The adjacent side is B, and then the hypotenuse is A. Why is A high the hypotenuse? Because A is facing directly across the 90. So here's cosine theta. Be right here. Here can also be a kind of tricky problem. If you don't read the question correctly, it says according to the FDIC, the average savings account interest rate in 2024 is 0.47%. If you place X dollars in a savings account, the total sums S available after n years will then be represented by the equation below. Say you put 10,000 in a savings account, how much would you have gained after 5 years round to the nearest dollars? Okay, so let's just fill in what we have already. So n is the amount of years, so it says after how many years? after 5 years. So my n is going to be 5. And then the x represents your initial pound, your initial val your down payment. So they say that you put down 10,000. So my x is 10,000. So yeah. Okay. So it's going to be s equals 1.0047, and then n is 5, and then x is 10,000. And when you put that in the calculator, this is what you get. You get 10,237.2194. Now, you don't see our answers. None of these are this amount, right? You don't see. But they're saying how much would you have gained after a year? So if you started 10,000 and then you're left with this, it grew this amount after 5 years, you want to know the growth. So basically, it's just this amount minus your initial value, your initial amount, 10,000. And when you put that in, you should get about 237. They want it to the nearest dollar, so yeah, 237. So yeah, that can be a trick question. Yeah, you could yeah, that's why you have to be careful with these word problems. Okay, so you have grown $237. Find the amplitude and period of this graph. So we have a sine graph, y equals 3 sine of 4x, right? Um, how do you find the amplitude? So the amplitude is a number in front of the sine. So our amplitude is 3, or the absolute value 3, which is 3. And then my period for a sine or a cosine graph is 2 pi over b. And my b value is the number in front of the x. That's what it's always going to be. So our b value in this case would be 4, but it can be reduced by 2. That's pi over 2. So that is my period, which is pi over 2, and my amplitude is 3. 2 is 3, and then my period is pi over 2. Yeah, it looks like C. Okay. This one, which graph represents the function f of x equals 3 over x minus 2. So this is a rational function. And how do I know it's a rational function? Because it's in a fraction form, right? It's in a p over qx form. That's how you know it's a rational. So in order to graph rational, you need to find the vertical asymptote. And how do you find the vertical asymptote? Basically, you set the bottom to 0 and solve for x. My bottom is x minus 2. Set that to 0. Solve for x by adding 2. Get x equals 2. And then how do you find, then you need to find your horizontal. So it's y equals, so what you do to find the horizontal is look at the highest term on the numerator and the highest term on the denominator. So your highest term on the numerator is just 3, or 3x to the 0. And your highest power on the denominator is x, or x1, right? Then what you do is figure out your rules. This is technically bottom heavy. So when it's bottom heavy, your horizontal asymptote is actually 0. And please don't say none, because that's false. It's 0. So if you kind of graph it a bit, because you have two asymptotes, right? That's good. Okay, so my vertical asymptote is 2. Here's 2. Draw like a vertical dashed line like that. And then my horizontal asymptote is y equals 0. Let me use a different color. So y equals 0 is right here. Okay. And then what we got to do is figure out what the right and left side is going to be. So what you're going to do is test some point. So I cannot use the x value 2 because that's my vertical asymptote, but I could use the x value 3 and I could use the x value 1. That's what I'm going to do. Plug in 3 and you get 3. It's 3 and then 3 minus 2 is 1. So you have a point at 3 comma 3 right there, right? And then if you kind of draw your line, see how it'll never cross the red dash line like that. Now let's test the x value 1. That's 3, and then 1 minus 2. 1 minus 2 is negative 1. That's negative 3. So you have a point at 1 comma negative 3. Okay, so it's going to look something like this. So be careful. I first thought it was A because it does have a vertical asymptote 2, and then it does have a horizontal example. Horizontal asymptote at y equals 0. But look closely. Our point 1 comma negative 3 should be right here. That's not where it is, right? So that's why it's not A. So be careful when yeah. Is it B? Let's see. Vertical asymptote 2, yes. They don't really show it to you, but if you like draw a dashed line right here, 2, and then horizontal asymptote at y equals 0, yes. Let's look at our points. So does the point 1 comma negative 3 fits out? Yes, it's right here. Does the point 3 comma 3 works out? Yes, right there. So this graph checks out. It's B. Okay, so rational function, find the vertical and horizontal asymptote, and then just graph some additional points. That's it. Okay, this one, we have cosine squared of 3 halves of x plus 4, cosine squared of 1 half of x plus 4, plus sine squared of x plus 4 minus 1. So what I would do is, this is multiplication, cosine squared of 3 halves, parentheses x plus 4, times cosine 1 half of x plus 4. So what happens when you multiply with the same base? So is equivalent to saying x3 times x2. You add the powers, right? 3 plus 2 is 5. So let's add 3 halves and 1 half. And you get 4 halves, which is 2. So this is now going to simplify as cosine square of x plus 4. And then you have this plus sine square of x plus 4 minus 1. Okay, so this stays the same now, and then when you multiply these out, you get cosine square of x plus 4. Now, is there any identity you could think of? Yes, the Pythagorean identity, this one, cosine square of x plus sine square of x equals to 1. So what happens is this whole thing is a Pythagorean identity, and that becomes 1. And then you bring that, you're still left with that negative 1, which now becomes 0. So letter D. Okay, this one, this one can be a little bit tricky, but it's really not. Um, the electric force F, the electric force F between the two objects with charges of C1, C2 separated by a distance big R is given by the formula below where K is a constant. How much would the distance between these two objects need to shrink in order to double the magnitude uh, of this force? So what they're saying is you're going to double your force, so that's going to be 2F now. and they want you to solve for big R. Okay, so you're going to double the f and then solve for big R. These are all K, C1, C2, they're all constant. So maybe that could be all just be one because constants is constant. So let's pretend K and C1, C2, it just becomes one. And then R squared is the same. And then this F now becomes 2F. Okay, then what you're going to do is solve for big R. So you can cross multiply. That's going to be 1 equals to 2F R squared. And then solve for R. So you're going to divide both sides by 2F, 2F, and you get R squared here, and then it's 1 over 2F, or you can forget the F because we only care about the constant, and then solve for R. So R is going to be square root of 1 over square root of 2. And we know that square root of 1 is 1, and then you have square root of 2. So let's see. Question 23, solve the equation. So what I would do first is we have square root of x plus 21 plus 5 equals to 17. So what I would do is subtract 5 from both sides. And now you get square root of x plus 21. And then 17 minus 5 is 12. Then in order to solve for x, I gotta get rid of this radical by squaring both sides. Over here, what happens when you square a radical? It disappears. So you're just left with x plus 21. Over here, 12 squared is 144. And then continue solving for x by subtracting 21. And you get 144 minus 21 is 123. Okay, so x is equal to 123. Okay, next one. Find the solutions to the given equation, tan of 2x equals 1 over the intervals from negative pi to pi. So this one is a little bit tricky. Okay, so it says we can only go from negative pi to pi. So if you draw your unit circle, pi is right here, and then positive pi is right here, quadrant. Here's quadrant 1, here's 2, here's 3, here's 4, right? And then negative pi is this way. So it looks like we can use 1, 2, 3, 4. Now, don't worry about this 2x. Pretend this 2, ignore this 2x or just worry about the tan of 1. What does the tan of 1 mean? It's basically saying what degree in radians is going to give you a tangent of positive 1. So tangent is the y over x coordinate. So I think we could use in quadrant 1, I can use pi over 4 because it does have an x coordinate radical 2 over 2 and a y coordinate radical 2 over 2, right? Because the y over x gives you 1. So we definitely can use pi over 4. I don't think we can use anything in quadrant 2 because it will never give you a positive 1 because the cosine is negative and the sine is positive. So that'll never make it into positive 1. I think we can also use quadrant 3, and that would be that would be let me look at my notes. That would be negative 3 pi over 4 because we're going backwards. So we're not going positive 3 pi over 4, we're going negative. So it would be also negative 3 pi over 4. And then what you're going to do is solve for x. So you're going to divide each term by 2, right? So what is pi? So now this is x. What is pi over 4 divided by 2? That's a complex fraction. So you can rewrite this as pi over 4 divided by 2 over 1. And then cross multiply. That's pi over 8. And then over here, what's negative 3 pi over 4 divided by 2? That's negative 3 pi 4. And then if you cross multiply, it's negative 3 pi over 8. So as you can see, it's going to be pi over 8, negative 3 pi over 8. I think it's D because it definitely has pi over 8 and negative 3 pi over 8. This 5 pi over 8 because we can go around the unit circle one more. Um, yeah, they had that 5 pi over 8. So as long as you have this negative 3 pi over 8, this pi over 8, it has to be it. The other ones does not have those, right? So it has to be D. Okay. Question 25. April sells golden apples for 1,500 apiece. If she sells 25 apples in a single weekend, how much money does she collect? So basically, it's as simple as that. It's really simple. It's just 25 times 1,500. And when you do that, you get 37,500 under D. Question 26. We have x squared plus 3x minus 4 over x minus 1. So what you want to do is just factor the numerator, which can factors out nicely, as x, blank space. What two numbers multiply negative 4 and added gives you 3, 4 and 1. And I'm going to use positive 4 and negative 1. And then it's all over x minus 1. And as you can see, the x minus 1 cancels, so you're left with x plus 4. D. Question 27, the cube root of 64. You could use a calculator. You can also say it's the same thing, 64 to the 1/3. So is this a perfect cube? I believe so, right? Um, you could put that in the calculator and you get 4, right? So one number times itself 3 times gives you 64. It would be 4 because 4 times 4 times 4 is definitely 64. Okay, let's see. 28. Simplify 16 over 9 raised to the negative 3 half. But what you could do is rewrite this as a positive exponent. So as a positive exponent, it would be 1 over 16 over 9 to the 3 halves. And then just simplify it. 16 over 9, 16 over 9 to the three positive 3 halves is the same thing as a square root of 16 over 9 times 16 over 9 times 16 over 9, right? So when you simplify this, this is 1 over, and then the square root of 16 over 9 comes out nicely. The square root of 16 is 4, the square root of 9 is 3, and then you still have these other two. So it's basically 4/3 times 4/3 times 4/3. Okay, so you get 1 over, and then on the bottom, what's 4 thirds times 4 thirds times 4 thirds? Well, that's going to be to the 30 is 64, and then 3 times 3 times 3 is 27. You have a complex fraction, so that's going to be 1 divided by 64 over 27, and then cross multiply, so this is going to be 27 over 64, and can it be reduced? I don't think so. Yeah, 27. Yeah, that's D. Almost there. Few more, two more. Convert the following equation to its exponential. So we have ln of x equals 2x plus 4. I notice there's an ln, so that means I have to take the e of both sides, raise everything to the e. Because whenever you see an ln, you do the inverse of each other, right? So on the left, ln e cancels, so you're left with x, and then this is e raised to the 2x plus 4. And that is going to be C. Okay, this one. Solve the equation. We have log of x squared plus 4 equals 2 log of x plus 1. So I notice they're all they both have a log. That's good. You can eliminate the logs and then bring down. But before I do that, I have to simplify the right side. We have 2 log of x plus 1. Well, what happens when you have a number in front of the log or ln? When you expand it, that becomes a power. So this can be written as log of x plus 1 squared. And then on the left, it's log of x squared plus 4, right? Okay, and then what you could do is see how they both have logs. That's good. Ignore it. And then bring that down. Okay, and then x plus 1 squared, when you FOIL that out, that's x squared plus 2x plus 1. Here you have x squared plus 4. And then you're going to get one side 0 by subtracting x squared. And then subtract 4. So I get 0 equals to 2x, and then 1 minus 4 is -3. Solve for x, you're going to add 3, you get 3 equals 2x. Divide this by 2, and you get x equals 3 halves. Letter A. Okay, so this is Alex exam 2. We'll continue more on more practice exam. Or should we test? Let's test our answers real quick. I believe we got 100, but let us double check. Yep. Oh, got one wrong? Okay, let's see what we got. Rational exponents. Wait, which one is wrong? It looks like we got all right. Oh, It should have been 27 over 64. Uh, let's see, what did I do wrong here? 16 over 9. So it's 1 over 16 over 9 to the positive 3 halves. That's 1 over, and then this is the same thing as square root of 16 ninths times 16 ninths times 16 ninths. And then the square root of 16, the square root of 16 over 9 comes out nicely as square root of 16 is 4, the square root of 9 is 3. We get 4 thirds times 4 thirds times 4 thirds. And then 4 times 4 times 4 is 64. And then 3 is 27. And oh, I see. So you have a complex fraction. This is 1 is your numerator, 64 over 7. Thus written as 1 divided by 64 over 27. Cross multiply that the 27 is definitely in the top and the 64 is on the bottom. Okay, so I made a simple mistake, but don't make that mistake when you take your exam. So the correct answer is B. Okay, I'm going to stop here.